So I think I will start from little intro. So as you see, my name is Oleksii, and I have about 15 plus years in industry, and I think I keep telling that almost for the 5 years. So have a lot of experience of different projects. Been through them in as an engineer, as a team leader, sometimes as an architect, or just an expert. Um, so I worked for different domains, I would say. So I have some experience in retail, in automotive, in healthcare, and financial sector. And my current presentation is not really about how making a codes or making containers running and all the stuff. It's more about planning and finding the right tools for the customer needs. So I want to share with you the story regarding one of my cases. I've doing planning, estimating uh, the cloud migration, and basically choosing the platforms that will be the new background or new digital backbone for our client. So let's talk a little bit about the client. So it is a company that mostly focusing on retails. It has lots of brands and it works on different markets with different culture. And that's why they have very different uh, culture of doing SDLC, way of doing their sites, like their marketing sites and sales platform they're using for their businesses. And that leads to significant struggle, I would say, when you need to do something across all uh, all the brands. For example, bonus programs or kind of marketing event. Uh, so we have a large scale of different tool sets and approaches, and that's a problem for them. So they want to have a new kind of doing application lifecycle management from the very beginning when you start thinking and generating idea regarding what your application would looks like in future through the SDLC and then to the operational part of that application. So the major things that should be in the new application lifecycle management is trends that here to stay for long. For example, containers. They definitely stay here for long, as the virtual machines were 10 or 15 years ago. Uh, Also, they want trusted vendor that makes updates and functionality changes wisely, not breaking the stuff that still works on their uh, technologies, and also be flexible enough to use new opportunities like new technologies or new approaches or basically the new trends that will come in the future. Okay, so why they want to build that platform? So it sounds like obvious, but we need to define that. So we need that to support our future growth. So we need the resilient build resilient infrastructure and agile, be agile enough to adopt new trends and new tool set in future. So how we're going to do that? So we need a standard platform uh, that will be aimed to reducing efforts, risks, and cost of ownership. Well, most most DevOps products claim that, and introduce tools that will streamline all their streams, all their brands. How to do that? It's built on currently leading trends like infrastructure as a code, GitOps practices, zero trust, and others. Okay, so considering all of that, we define the strategy that this client will go. So it will be shared ALM platform that will support end-to-end delivery for all the streams, that will consolidate the landscape, introducing the platform that where all their different technology can live together, but sharing the same platform, same process, same management way of managing things, monitoring and testing, and transform the way they do businesses. Introduce DevOps culture. They don't really have that for some streams, and introduce the way you deliver things. Okay, that's a lot of fancy words, but let's look at how we will approach that. So first of all, to make some changes, you need to have a focus areas that you will do the changes. So we defined several of them. So it will be backlog management, because how managing your backlogs, your user stories, having the traceability there, having things like versioning inside your artifacts. So it uh, starts with your backlog, then tasks. So source control. Basically not a big issue nowadays because most system uses Git, maybe a kind of different flavors, but they're all compatible, so not big deal. But anyway, you need to have it in one place to make it secure, for example, to introduce GitOps there. So configuration management and infrastructure as a code. So for old system, you still need configuration management to support them while you be doing their transformation. And infrastructure as a code is the way to go nowadays. So test management, it's a huge part that often not considered in DevOps or cloud transformation, because that's the way how you basically ensure that you have quality in your product. So that's next focus area. Of course, the continuous integration. You should have not saying one tool, but one principle of doing continuous integration with the quality gates, code reviews, and all that things. And static code analysis will help you with that a lot. So artifacts management. So you definitely want to have the artifact delivery model, not source code delivery model, for this kind of uh, services client have. And then you need to focus on the release management and reduce the landscape, create a single platform that in some degree will satisfy most of the company services and sites. Okay, so if we look at the current tool set that this company have, so basically it's not much. So I did this kind of assessment. So that's a major platform thing that was introduced through that services, brands, etc. So it was several flavors of Azure DevOps, TFS, and also on-premises and cloud version, different virtual machines, several container instances, several web apps, also, of course, Jenkins, of course, Bitbucket, and some Ansible. But if we look at the details, I hope you can see that. So this example shows only 5 brands of that company, but it definitely has more. We can see that for each brand, we don't have such things like static code analysis. For most of them, we don't have consistency across CI tools. Basically, they correspond to what is used for release management. And however, you mostly have Jira, Jenkins, Bitbucket spreading across organization and hosted on different platforms with the different ways of managing. And that causes some mess around that. But supporting that, operating, updating, synchronizing work, or even knowledge management in the Confluence. So for the new platform, the most obvious choice was use Azure DevOps, as it has most functionality already on the board. So the new landscape looks like that. So we have Terraform for infrastructure as a code, Kubernetes for microservices, web apps for running sites and all the things that we don't want to see in Kubernetes cluster for various reasons. We have standard Azure DevOps for managing our backlogs, code, PRs, pipelines, both CI and CD, also test management, and well, runner of the Sonar Cube that and other tools that will just be integrated to the pipeline and gives immediate feedback about what's happening in our with our code on the particular stage. So why Azure DevOps? So it's integrated, so it's already a platform, and we are seeking for the platform to build our services upon, to build our processes upon. So it already have almost 70% of the tool set. It is not the best in all areas, but it's definitely can compete with other platforms, and it's greatly benefit from the integration it's already have out of the box, like traceability. So you can trace your user story from the commit you made to the deployed application, and you can see what test was run, and of course if you manage the test inside the Azure DevOps. So you have one licensing model. You don't need to have several of them. You have already integrated services. So not saying regarding, can I say that it's regarding Jira or Confluence. It's always a pain. And you have simple but effective dashboards. So that why the choice was made in this area. So next, as we defined what tools we will have, and we know that some tools fits all the stuff, we need to think about how we will approach that. So what will be needed? So we basically need to estimate that and say what to do first. Are we going to start from migration everything to the containers, containerizing everything we can, or just start from the moving the backlogs and source control, or start from making the test and integrated our Sonar Cube and other scanners to our Jenkins pipelines, for example. So for that purpose, we did some kind of estimation that will show us the value and the complexity. And so we basically draw bubbles. And the size of that bubbles means what is meant to you to implement. Uh, I think we will use the next slide because this one we lost some text on it after slide transformation. But anyway, let's use this one. So basically, we have complexity, uh, value that it gives, and effort. So we did our estimation, grouping our focus area to some series, and um, basically using the T-short estimation technique, some extended to some degree. We did estimation from the standpoint of the standard DevOps team of 3 persons per every stream or every brand, and basically calculating their man days and converting to value you can see here. So that's whole another story how to make the estimation work in a digits, let's say. So what we can see here that our source control gives us not much of a value, but it's very simple thing. So moving backlog give us a little more value because together with source control, you will gain the traceability, but requires more effort for putting things to the system. So static code analysis, it's something that is easy to implement, easy to add to your current pipeline, and it gives you quite a lot of value because it gives you the feedbacks, what is wrong with your code just immediately after CI build. So it positioned here. Uh, Release pipelines and CI pipelines. So we all know that this most valuable thing in whole CI/CD. Like it's a background that everything is built on. Infrastructure as a code, it could be complex. Managing it could be complex. Adding new things also complex. But the most complicated thing here is testing and monitoring because well, you can invest in test almost continuously and never never get to this sweet 80%. So it's on the top from the value and from the complexity standpoint. So after that estimation of every area, it's time to put this on the roadmap and think how we will approach the transformation in the time manner. That's basically what we did. Um, so here we can see our groups of activities or focus areas from source control to the backlog management to the infrastructure changes, CI/CD monitoring and testing. And the timeline that uh, we consider to run these activities in parallel. Basically, they don't have too much dependencies to each other, so you can run it in parallel. You can run it in one by one. But the most interesting points that what you're getting after, for example, having the SCM migrated and the backlog management migrating, you had that traceability. Yeah, you're getting the traceability through the your user stories to the code, to the commits, to deployed artifacts or stored artifacts in some registry. So for the old system, if you introduce a configuration layer management, because we have to admit that our virtual machines will live for some time, maybe for 5 years, maybe less. So we get a consistency here. So to have a auto scaling, we need to have our infrastructure as a code. We need to change the platform for our services. And we also want to know how this auto scaling, how much it will cost for us. So that's three things that will enable us to say that we can now support auto scaling. I'm not saying that we will do auto scaling for everything, but it be able to support that. So the same is with consistent feedbacks and quality gates. So next enables it's release pipelines, CI builds, of course, static code analysis, and basic tests like unit tests and integration tests. I'm saying that it is very basic stuff, but it's beneficial to have consolidate feedback and set up quality gates, and then we can have and can ensure that system has quality inside according to all of these things. So last part, it's security, stability, and resiliency. So security, it's almost what we get from static code analysis and security testing. To make infrastructure resist some dangerous situation on some failures, we need to build platform that are resilient. We need to build this transformable services to make it resilient, and then have monitoring with behavior predictions. So that will allow us to say that after some certain markers, we will have failure in the future, in a day, in an hour, or somewhere in the nearest future. So the same is for the system stability.
Please tell me, what is the worst thing, the most challenging thing you have to challenge?
Well, the most challenging thing for the technical person when you start doing assessment and start talking with the business is to understand what the business really needs, because uh, it's how to say that so ideally you should give a business what he wants but not what he requested, because the request can be very blurry and, well, not exact, I would say.
Yes, I heard this Polish channel creators, so creatorzy, and they also have about funny movie about that. And I heard this a lot of times. Clients want a Porsche, and what is really neat is a scooter. Is that true?
That yeah, that's true in uh, I think most cases. Uh, well, through what I've been through my consultancy career. Yeah.
Okay, I'm sorry. I made a little bit disco here, but I don't want to interrupt you. And what about the vendor lock risk for this kind of infrastructure you are talking about?
So that very common question, uh, and the answer will vary depending on a situation. However, if you think about what is really the vendor lock and why you should avoid it. So if you're choosing the partner, for example, you're building new LM process, new LM platform. So that means that you will rely on that platform for, I would say, for 10 or 15 years. As you, as example, you rely 10 for 15 years to the VMs, and you rely on Git. You can maybe rely on some Oracle databases. So that definitely something that can be considered as a vendor lock. So is it good? Is it bad? So if you are going or something happen and now you have to move away from your desired platform, your desired ALM process. So it could be an issue. So that's why nowadays the technology and trends we have basically have the ability to, well, to some degree, not risking too much. For example, if you doing just the containers, you can run it mostly on every platform. Of course, with the tuning, of course, you have to do some shifts in configuration, but it's basically self-sufficient. So all the runtime is in the container. So it made of code, it consists code. So nothing stop you from easily migrating it somewhere. Working in such way with older databases, it's hard thing because you cannot transform the data too easily or just change the platform. It's possible, but it requires a lot of efforts. Yeah. If you're using the cloud services, that basically serverless or headless, so that definitely you're definitely locked to, well, if you write your services the way you can write your services the way that you will have that lock. However, it can be not such a big deal. You should look at that from the point of how long we will use that application, what is lifetime of that application. So, for example, if it's service that you're going to use for 2 years, and then it will retire and will be replaced, or you're using it for some transformation purposes. So that's completely fine. Why should you change the platform, change the vendor during next 2 years? So that will be my answer.